Hi everyone, in this video we're going to go through 16D, solving problems using the normal distribution. So just forgot to plug in my tablet, so I'll just quickly do that. So basically we're just going to apply everything that you've learnt in 16A, B and C to worded problems, okay? So how we would apply the normal distribution in real life situations. I think I'm only doing about 6 questions in this video. So if you want some additional practice, you can go and do the questions that I haven't covered in the video. It's good to practice them. Normal distribution isn't overly difficult. So if you're okay with these questions, then I would just focus more probably on the other sections. So discrete random variables and continuous random variables. All right, let's make a start. So question 1, suppose that IQ scores are normally distributed. So whenever you see normally distributed, always think of the bell-shaped curve. Okay, so there's your bell-shaped curve, your normal distribution. Your mean is 100 and a standard deviation of 15. Okay, so your mean always goes in the middle. So if you wanted to draw it, you can, but you don't always have to. And sometimes it might take you a bit of time to draw it, and in an exam, you just don't. You got to save time as much as possible. But if I was to draw this as a normal distribution, there's your mean in the middle, and then we go up by 15 each time. Now we've done IQ scores before. What have we got? 85, 70, and then 55. So just 3 standard deviations either side of the mean. All right, so with this question, we're looking at, or we're wanting to find IQ greater than 110. Okay, so if I look on here, 110 is not 1, 2, or 3 standard deviations above. It's somewhere between 100 and 115. So we're going to have to use our calculator. We're also going to have to use our calculator for less than 75. All right, and then question 3, we have a conditional probability. And even though 130 is on here, and we can calculate what that is using our 68, 95, 99.7% rule, we're just going to use the calculator. And then 110 we'll also use on the calculator. Question B, to be allowed to join an elite club, a potential member must have an IQ in the top 5% of the population. So again, we can't use the 68, 95, 99.7% rule that we covered in 14B. We are going 14B, 16B, sorry, we're going to have to use the calculator. All right, so let's make a start. So for question A, part 1, we want the probability that X is greater than 110. All right, so grab the calculator, and there's my calculator. All right, so remember, you can either go to the interactive or we can go to the statistics. I always think the seeing it visually on the statistics screen is better because, we're doing greater than or less than. So you just want to make sure it's shading the correct region. And let's make sure I'm actually choosing the correct thing. All right, so normal CD. All right, so your lower bound, if we're greater than 110, our lower bound is 110. And our upper bound is infinity. So keyboard, and we're just going to use the infinity symbol. All right, standard deviation, so don't get your standard deviation and mean around the wrong way. So our standard deviation is 15 and our mean is 100. I'll just get rid of the keyboard so we've got a bit of space on the screen. All right, so you can see it's written there, but let's just draw the graph as well, just so we can make sure we've highlighted the right section. So we want greater than 110. Okay, so there it is there. And we got 0.2525. All All right, so with all these probabilities, just do them to 4 decimal places. All right, for part 2, we want less than 75, so x is less than 75. Calculator. All right, so just put the values in. So your lower bound now is negative infinity. Your upper bound is 75. And your mean and your standard deviation stay the same. Get rid of the keyboard. And just press your graph again so we can redraw the graph. Okay, so less than 75. And even drawing your normal distribution will help. So what is that? 0.478. 0.0478. All right, for question 3, we want greater than 130 given that they have an IQ greater than 110. Okay, so let's set up our notation. So we want the probability that x is greater than 130 given that x is greater than 110. All right, so it is conditional probability, okay, and that's shown by the word given that. Just make sure you write your question correctly. So the condition is the second one. So given that this is your condition. Okay, so we want the probability x is less than 130 and x is greater, sorry, did I say less than? Greater than 110 over probability that x is greater than 110. Okay, so you can draw a number line if you want. So x is greater than 130 is also greater than 110. And I've just realized I don't have much space here. So let's see if I can just move this down a little bit. Okay, so we want the probability that x is greater than 130 over the probability that x is greater than 110. So we've already done x is greater than 110. Okay, we did that in question A, part 1. All right, so that's 0.2525. So let's do greater than 130. Let's just find my calculator. So we want 130 and infinity. Oh, come on. There we go. All right, so what is that? 0.228. Now, if you wanted to, you can put that into the main screen. You can just copy and paste it. So 0.0228. Oh, I feel like I wrote the wrong number. Did you know that's right? So if you wanted to go into the main screen, you can just copy and paste or do, just go back onto the main. You can use the interactive here and so normal CDF, and you can do it there as well. So it might be easier to drag the numbers going from the main screen. All right, just move this over. So we've got 0.002, oops, 0.0228 divided by 0.2525. And I get 0.0903. All right, when I just checked that answer in the textbook, I had a different answer. So the answer in the textbook was 0.0901. So probably shows the importance of not rounding. So I probably shouldn't have rounded there. All right, so just as I said before, it's probably better to use this one. So continuous normal CDF, put your values in there. All right, and then get your, use more decimal places. Okay. So I might actually change that because I know some of you don't watch the video. So I might change that to 0.091 and then just put a little asterisk. Don't round until the end. Till the end. All right, and then question B, to be allowed to join an elite club, a potential member must have an IQ in the top 5% of the population. What IQ score would be necessary to join this club? All right, so let's just move that down again. So question B, we want the top 5%. So we want the probability that X is greater than some value. So we can just call that K, C, or whatever. Top 5%. So we want value to be greater than K is 0.05. You can do it the other way. All right, you can do the probability that X is less than K is equal to 0.95. Remember the symmetry. Okay, but we'll just stick with the first notation. All right, so the probability X is greater than K is 0.05, so the top 5%. So on your calculator, let's just do it from this screen. We want inverse, normal. Is it going to come up? Try again. Oh, sorry. Try it again. There we go. Okay, now you can't see my whole calculator, so I might just move it back. All right, so we want the area to the right. So just make sure you select the right. The probability has to be 0.05. Standard deviation for this question is 15 and the mean is 100. All right, so 124.67. And tell us to round to anything. All right, so you'd probably, if you had to round, probably 125 or 125. All right, moving on to question 3. So the results, the results of a mathematics exam are normally distributed. All right, so it's telling us it's normally distributed with a mean of 50 and a standard deviation of 7. What is the probability that a student chosen at random? Okay, so we've got a similar question to the one previously. All right, so perhaps stop and see if you can do this question on your own. Okay, so if we were to draw this as a quick normal distribution, our mean is in the middle, 50, and the standard deviation is 7. So we're going up by 7 each time and down by 7 each time. Just make sure I've done that correctly. Okay, so these percentages we can't get from the 68, 95, 99.7% rule. So we're just going to have to use the calculator similar way to we did before. So I'll just use it straight from the main screen. All right, greater than 60, so our lower bound is 60. Excuse me. Our upper bound is infinity. This time our mean is 50 and a standard deviation is 7. So just make sure you don't get them mixed up. And it does say there what it is, population mean, but you tend to just look at the symbols. And if you think you're going to get the symbols mixed up, just remember to look here. All right. All right, so an exam mark greater than 60. If I look here, all right, so 0.0766. All right, so that looks pretty legit. All right, we're looking at quite a small proportion. All right, for the second part, we want less than 75. So again, going to distribution, continuous, Normal CDF. Okay, so this time our lower bound is negative infinity. 75. And you'll notice I did this a bit different to the previous one where in the previous one I used the graphing screen or the statistics screen. Okay, so it's either one you prefer. All right, less than 75. So if I just look at my normal distribution, 75 is up here. So we kind of will have quite a large area. And you can see there on your answer, what did I get? 0.9998. So that's quite high. 0.9998. So the majority of people will get less than 75. Question 3, or part 3. All right, so we want probability that x is greater than 60, given that they passed. Assume a pass mark of 50, so x is greater than 50. All right, if I was going to write that with the conditional probability notation, so it's a good idea to get into this habit just so you get familiar with the formula. So probability that x is greater than 60 and x is greater than 50 over the condition, so x is greater than 50. All right, so what values are greater than 60 and also greater than 50? So that's just going to be x is greater than 60 over the probability x is greater than 50. All right, did we do either of them before? We did do greater than 60. 0.0766, and remember we rounded that value, so we're not going to use the rounded values. Let's just do that on the calculator. What you can do also, I just realized this, you can also just highlight this, go down and just change that 60 to 50. Oops. All right, so 50%. Oh, we should have known that. All right, so I'm going to highlight this value, all of it, drag it down, divided by 0.5. So just more accurate if the more decimal places you're using. All right, 0.1531. All right, part B, the top 15% of the class are to be awarded a distinction. So this time we want probability that x top 15%, so greater than some value, is equal to 0.15. So just changing that 15% into a decimal. If you're not sure how to do that, just move your decimal place 2 spots, or it's the same as 15 over 100. Don't know why I changed the colour. All right, so 0.15. All right, so on the calculator again, so this time it's inverse. So if you're finding not the probability, but the value, what are we doing? Continuous, no, inverse, inverse normal. All right, so this time we want to the right. Probability is 0.15. Your standard deviation is 7 and your mean is 50. All right, and we get 57 point, just do 2 decimal places, 26. All right, so that's the mark. If you get above that mark, you get awarded a distinction. All right, moving on to question 3. More space. The height of a certain population of adult males is normally distributed with a mean of 176 and a standard deviation of 7. So question A, find the probability that the height of a randomly selected male will exceed 190. Okay, so A, the probability that X is exceeding, so greater than 190. All right, so we just do that on the calculator. All right, so our lower limit is 190, our upper limit is infinity. And I remember our mean and standard deviation, 7 for our standard deviation and 176 for our mean. All right, so 0.0228. All right, so if two males are selected at random, find the probability that both their heights will exceed 190 centimeters. Okay, so we want, all right, so two men, we want the probability that X is greater than 190 times the probability that X is greater than 190. Okay, so we've got the two men. So we're multiplying their probabilities. So we did that before. Okay, so that is the same as 0.0228 squared. Now on your calculator, when you do that, you get this answer. So just remember, you need to be able to interpret that. But if you wanted to, we can just write that as, I'm not going to do too many decimal places. I'm going to do 5.2. All right, and remember that 8, you can just replace 10. Okay, sorry, just had a bit of a coughing fit. All right, let's now write that without the scientific notation. So the -4 means we move our decimal place 3 spots. So we'll keep that 5.2 there. Decimal spot was here, so we've got 1, 2, 3, 4. So your answer is, we're just doing 4 decimal places, 0.0005. So two males are selected at random. What is their probability of both being 190 centimeters? So very tall. So we know that's already rare. So getting two men at that height is extremely rare. All right, part C, suppose 10 males are selected at random. Find the probability that at least 2 will have heights that exceed 190. All right, so this is a binomial distribution question. Okay, so we've got 10 males are selected at random. So our value of n is 10. And our probability, so we've already worked that out, so we're still dealing with men who are greater than 190 centimeters. So that's 0.0228. And we want to find the probability that X at least 2, so greater than or equal to 2. So our lower limit is 2. Remember, we're now using discrete values because we're looking for 2. So our lower limit, at least 2, so greater than or equal to 2, and our upper limit is 10. So on our calculator, I'll just move this over. All right, we want discrete, binomial. All right, so our lower limit is 2, our upper limit is 10. The number of trials is 10, and the probability of success is 0.0228. All right, so 0.0207. All right, again, I probably shouldn't have used the rounded value. So what I'm going to do is highlight this. And instead of using this rounded answer here, I'm going to delete that. And I'm going to drag this unrounded value down. All right, and then press enter. So you can see it's 0.0206. So I'm going to change that 7 to a 6. So just be careful with your rounding, which I'm not. I should have been from the start. All right, how many questions have we got to go? Quite a few. So guys, it's probably a good idea, if you're getting the hang of it, just pause and have a go at doing it yourself. All right, question 10. The weights of pumpkins sold to a greengrocer are normally distributed with a mean of 1.2 kilos and a standard deviation of 0.4. The pumpkins are sold in 3 sizes. So we've got small is under, medium, and large. Find the proportion of pumpkins in each of the 3 sizes. Okay, so what I'm going to do, are they, oh good, I think these values, oh no they're not. I was thinking, are they straightforward? Okay, so let's do the small. All right, so we want under 0.8. So we want inverse and normal. Okay, so if we're looking under 0.8, so we're, for small, oh no, x has to be less than, I think my computer is going to die on me soon. Less than k has to equal 0. Oh, hold on. No. I'm getting a little bit mixed up. X is less than 0.8. All right, what I might do is keep going. Yeah, because I feel like my computer's going to die on me very soon. Okay, so this, then we've got 0.8 to 1.8, and then large, x is greater than 1.8. All right, so go ahead and do all that on your calculator. I'm not going to do that because I know my computer is about to die. All right, so there's your answers for the small, medium, and large. Okay, and they should add up to roughly 1. The prices of the pumpkins are $2.80 for a small, $3.50 for a medium, and $5 for a large. Find the expected cost for 100 pumpkins chosen at random from the greengrocer's supply. All right, so your expected value, I don't know why it keeps doing that. All right, so we've got 2.8, so $2.80 times 0.1587. And then the next one is 3.5 times your probability, 0.7745, plus, what is that, 5 times your large, so 0.0668. Now your expected value, all right, so that's your expected value. If we want to know the expected cost for 100 pumpkins, all right, we just multiply your expected value by 100. So just to save my computer from crashing on me, we're just going to do that. So put all that into your calculator and then do your expected value times 100. All right, and you get 348.92. All right, for the last 2 questions, I might just talk you through it just to keep the video a little bit shorter. But if you do have trouble, just please let me know. All right, question 11. Potatoes are delivered to a chip factory in semi-trailer loads. A sample of 1 kilogram of the potatoes is chosen from each load and tested for starch content. From past experience, it is known that the starch content is normally distributed with a standard deviation of 2.1. Okay, whoop. All right, so we don't know the mean. So normally distributed for a semi-trailer load of potatoes with a mean starch content. So there's our mean, 22. What is the probability that the test reading is 19.5 or less? What is the reading will be exceeded by with a probability of 0.98? So for both of these, let's just write the notation. So the probability that x is less than 19.5. And then for part 2, what reading will be exceeded with a probability of 0.98? Okay, so we want x to be greater than k, that's to be 0.98. So let's do both of them on the calculator. Let's cancel that first. All right, try again. Okay, so for the first one, we want x is less than 19.5. So our lower limit is going to be negative infinity. And our upper limit is 19.5. Our mean was standard deviation is 2.1 and our mean is 22. Okay, so we've got 0.1169. All right, and then for part 2, are we going to make it to the end? So interactive. All right, so inverse normal. All right, so the tail setting, we do want it to the right. The probability is 0.98. Standard deviation was 2.1 from memory. Let's just all right, and 22 for your mean. So 17.687. Sorry, should write K equals. All right, question B, if the starch content is greater than 22, the potatoes cannot be used for chips, and so the semi-trailer load is rejected. What is the probability that a load with a mean starch content of 18 will be rejected? Okay, so this time the mean starch content, didn't have my highlighter, is 18. All right, greater than 22. So even though that was our mean for the previous one, all right, it's different for question B. So we want to do, let me just get this up. The probability, what is the probability, mean starch content of 18? So it's got to be below that. Sorry, below 22. Sorry, let's read the question again. If the starch content is greater than 22, so x is greater than 22. Sorry. All right, we'll go back and do that on the calculator. All right, so greater than 22. So our lower limit is 22. Our upper limit is infinity. Standard deviation is 2.1, and this time our mean was 18. Okay, so 0.0284. All right, let's look at the last question, hopefully before the computer crashes. The amount of certain chemical in a type A cell is normally distributed with a mean of 10. All right, I might just write that. Type A cell, mean of 10 and the standard deviation of 1. The amount in a type B cell, it has a mean of 14 and a standard deviation of 2. To determine whether a cell is type A or type B, the amount of chemical in the cell is measured. The cell is classified as type A if the amount is less than a specified value C, and type B otherwise. Okay, so question A, if C equals 12, calculate the probability that a type A cell will be misclassified and the probability that a type B cell will be misclassified. All right, so we want the probability is less than a specific value. All right, so I might write this again. If the probability of X is, so let me just pause. All right, start again. So type A, so the probability that X is less than 12, so less than C. All right, so if we want it to be misclassified, so it's not type A, then we want the probability that X is greater than 12. All right, so on the calculator, let's make sure we've got it right. Interactive, distribution, continuous, CDF. All right, so we want greater than 12, so 12. Upper limit is infinity. Standard deviation, so if we're looking at type A, it was 1 and your mean is 10. So 0.0228. All right, and then we've also got to do type B. Now remember, your mean and standard deviation is the same for both of them. So B has to be the probability is greater than 12. So if it's going to be misclassified, so it's just the opposite to type A, the probability that X is less than 12. All right, so on the calculator, and keep it same, let's just highlight it and drag it down. Okay, so your mean and standard deviation are different for type B. So for type B, your mean is 14 and standard deviation is 2. So let's change the mean to 14 and the standard deviation to 2. All right, and I did my values around the wrong way, just realized that. So I'm going to just change that around. Oops, so that should be negative infinity. Sorry, I got my inequality sign around the wrong way. All right, so 0.1587. All right, so just make sure you know that type A and type B have a different mean and standard deviation. Find the value of C for which the two probabilities of misclassification are equal. Oh gosh. All right, so very tricky question, part B. So we want to find out the value of C for which the two probabilities of misclassification are equal. Oh, don't tell me everything's going to die on me. Let's just see how we go. All right, so for type A, no. All right, what I might do is I'll just talk to the solution because my computer is going to die on me very quickly. Okay, and they've probably explained it the same way as I would do it in my notes, okay? And at least it's not going to disappear on you. Okay, so for question B, we're going to let X be the amount of chemical in a type A cell. So X is normal with mean 10 and standard deviation of 1. Okay, so remember you were given that in the question. So type A has a mean of 10 and a standard deviation of 1. And let Y be the amount of chemical in that should be type B cell, not type 1 cell. So type B cell, So y is normal with a mean of 14 and a standard deviation of 2. So when we're looking at our probabilities, the probability that x is less than c is equal to the probability that y is greater than c. Now the thing is, because x and y have different means and standard deviations, you can't just assume that they're symmetrical. Okay, so what we do, and you can see this on the second line, is we've introduced the standard normal distribution, or the z-score, or the z value. So, and I don't think my counter is going to work here, so let's see if I can highlight it. So this part here is just calculating the z-score. All right, so x minus your mean over the standard deviation, that's your z-score, and then you've done the same thing for y. All right, so standard deviation over y minus your mean over your standard deviation. All right, so basically your z value, okay, has to be less than c minus 10 and has to be greater than c minus 14 on 2. So what you can see down the bottom here where it says hence, okay, you're just now solving for c. Okay, so you've got, because z has to be less than c minus 10, if I was to change that inequality sign, I've just put that negative out the front of the bracket so you can see that on the first line. All right, so just because you want z to be the same and one side is less than and the other side is greater than. All right, and then you're just solving for c. So c is equal to 34 on 3. Okay, all right, I'm going to end it there. I'm sorry I couldn't explain that with my own notes, but as you saw, Word is not cooperating today like most days. Okay, bye.